Alright, last video. This is 11.7. This is over equations of circles, so it's a little different than the first 6 sections. It is more algebra meets with our circles here. So we're going to put them in the coordinate plane. Alright, the equation of a circle is based on the distance formula and the fact that all points on a circle are an equidistance from the center. So we're going to start with this diagram over here. We're going to call the center H and K. Like this would be the X coordinate and this would be the Y coordinate. Then any random point on the circle, I could do this to any point. I'm going to call X and Y. So I want the X and Y to stay in the equation because X and Y can change all the time. So those are my variables. In this case, H and K are going to become numbers because whatever your circle is, it has one center. So we're going to have numbers to fill in for H and K for each individual problem. But I'm going to hold their place until I get the problem with H and K. So the distance formula is right here. And then, so what we're going to do is we're just going to replace the center, H and K, for one of the X1s and Y1s, and we're going to replace just regular X and Y for the other. So here we have X minus H and Y minus K. So X minus H and Y minus K. And that represents the radius. So this is where the formula comes from. All I'm going to do is instead I'm going to square both sides to get rid of the square root because the square root looks scary. But basically it's the same formula. So you can see that the formula for equation of a circle right here is exactly based on the distance formula. All I did is instead of X1 and Y1, I substituted H and K for the center. So that only two things you need to know to find the equation of a circle is where's the center and where's the radius. Once you have that, it's just a super simple game of plugging in. So in this case, the radius is 4. So we have 4 squared is equal to X minus, this is H squared plus Y minus, this is K. Now in this case, they're both the same, but it still works out. Okay, so then all I have to do is simplify. 16 equals X minus 2 squared plus Y minus 2 squared. That's it. That's all she wrote. The circle K passes through the point 6, 4 and has a center at 1, -8. So in this case, they didn't give me the radius. Remember, the two things I need are the center and the radius, and I don't have the radius, so I'm going to have to go find it. But I know if I have this point and I have the center and a point on the circle, all I have to do is distance formula to find it. Okay, so let's ask ourselves, how far is it between 6 and 1? Well, it's 5 places away, and then I square that. How far is it between 4 and -8? Well, that is 12 places away, and then I square that, and then I'm going to take the square root of the whole thing. Okay, so here we go. Well, that's a Pythagorean triple, 5, 12, 13. So the radius is going to be equal to 13. Now be careful. Remember way back from section 1, circle K, that means the center is at K. Don't use J on accident. So then I can go through and plug in. 13 squared is equal to X minus 1 squared plus Y minus -8 squared. Just do a little simplifying. 169 is equal to X minus 1 squared plus Y plus 8 squared. And that's it. Okay, if you are given the equation of a circle, you can graph the circle by identifying the center and the radius. So here we go. X squared plus Y squared is equal to 16. So this one, you can see, you know you find the center from whatever is with X and from whatever is with Y. But in this case, nothing is with X and nothing is with Y, so your center is actually going to be at 0, 0. You know that this represents R squared. So if R squared is 16, then the radius must have been 4. Okay, when you graph a circle, I'm going to require that you graph the center, of course, and label it, and then you graph at least 4 points. Now the easiest 4 points to graph are just left, right, up, down. Ignore that. Left, right, up, down from your radius. So 4, 0, 0, 4, negative 4, 0, and 0, negative 4. Okay, I'm going to let you do the next one by yourself, but I want to caution you about one thing before you get started. Remember that the signs of the center are always opposite. So like this one, the center was at 1, 8, but when I look at my formula, it's at -1, positive 8, because the minus sign belongs to the formula. This negative minus sign comes with the formula, so it doesn't come with the center. So when I see this, x minus 1, my center is at 1. Y plus 8, my center is at negative 8. So take that into account when you work on B by yourself. Alright, so if it's equal to 9, then that means the radius is 3. The center is at 3, negative 4, because I have to swap the signs. So I put my center here, and I go up, down, left, right 3 places, and label. Okay, we can talk about how to graph circles on the calculator in class tomorrow, but basically if you want to put this in your calculator, you know you have to solve it for y. So here you can see me solving the equation for y. Move x to the other side so he becomes negative, and then take the square root of everything to get rid of the y squared. Now what you have to remember is that when you take a square root, there's actually 2 answers, a positive and a negative answer. We in geometry usually only use the positive answer because line segments and angles and all that can't be negative. But in algebra, which is what we're working on here, they have to use the positive side and the negative side. So we would graph the positive side in y1 and the negative side in y2. And again, we'll do this together in class tomorrow when we all have graphing calculators. Alright, word problem. An amateur radio operator wants to build a radio antenna near his home without using his house as a bracing point. He uses 3 poles to brace the antenna, and the poles are to be inserted in the ground at 3 points that are equidistant from the antennas located at those points. What are the coordinates of the base of the antenna? So I'm going to zoom back in on this. So basically, if all 3 of these points have to be equidistant from there, one thing that you could do, oh, that's really bad, sorry, is you could set up a circle going through those 3 points, and then we just need to figure out where the center of the circle is. Now, this goes back to chapter 5, and it actually goes back to the part of chapter 5 that we skipped because it's not going to be on the EOC. So I'm just going to tell you what's happening here. Because these 2 lines are perpendicular, I can count their slope and tell that these 2 lines are perpendicular. That means this is a right triangle. And a right triangle has an interesting property where the center of it is actually the midpoint of the hypotenuse. So all I have to do is find the midpoint of J and L, and that will be where I want the center of my circle, only because this happens to be a right triangle. So here we go. J is at 4, 4. L is at 2, negative 8. So add them up and divide by 2. So the center of the circle needs to be at 3, negative 2. And you can kind of see that when we guesstimated where the center needs to be, well, my circle is really crappy, but you can kind of give a good estimate that that's where it would need to be, and then we could use our math and our knowledge of triangles to actually tell us exactly where it has to be. Ready? Last page. Okay. A tangent line, we know this from section 1. A tangent line and a radius are perpendicular at the point of tangency. Remember that from like the spaceship problems? A radius and a tangent line are always going to be perpendicular. That is theorem 1151 and theorem 1152. So we're going to use that now with our equations of circles and kind of mix those 2 together. Alright, so write the equation of a line that is tangent to the circle x squared plus y squared equals 25, whoopsie, at the point 3, 4. So a couple of things we need. I need to know my center. So in this case, the center is at 0, 0. I need to know the radius. It's 5. Actually, I don't even need to know the radius. And the other point is at 3, 4. So I'm going to give this a quick sketch. Oh, I drew that in the way. I'm going to give this a quick sketch. And here would be my circle like this. That's not what I'm after. I already have the equation for the circle. What I want to know is what is the equation of this here tangent line to the circle at the point 3, 4. So one thing I know is that the tangent and the radius are perpendicular. So I know about perpendicular lines that they have opposite reciprocal slopes. So I'm going to start by finding the slope of the radius. So from 0, 0 to 3, 4, I rose up 4 and I ran over 3. So if I need my tangent line to be perpendicular to that, it would be negative 3/4. And you can kind of see just from our rough sketch how it looks like it has a slope of negative 3/4. So, well on my way for my equation of my tangent line. I have a slope, and I have a point that this slope must go through. So I'm going to use point-slope form. Y minus 4 is equal to negative 3/4 x minus 3. Distribute. And move this 4 on over. Now, I need a common denominator to add 4 and 9/4. So in an effort to not waste space, I'm going to do that at the same time. And instead of calling that 4, I'm going to call it 16 over 4. So then I have my final answer. Y is equal to negative 3/4 x plus 25 over 4. Right there. Okay, so just like all your algebra stuff, this is a process and it's going to be the same steps every time. Just insert new numbers. So find the center and you know the point, and you're going to use that to do slope of your radius, so rise over run. Do opposite reciprocal to make it be perpendicular. Then use your new slope and your point that it goes through, not the center or the point, and you're going to do point slope form and solve it out. Okay, do B. Same story. My center is at 1, negative 2. Here's my sketch over here. It's going through the point 5, 5. The radius, the slope of my radius is negative 3/4, so the tangent is 4/3. Point slope form, solve it out. Y equals 4/3 x minus 35 over 3. Last video done.